Annyeonghaseyo and greetings, ninth graders. Welcome to Energy Production. So today, I hope to have a shorter presentation. I just feel like lately I've been trying to make them shorter, and they've been like right around the 15-minute mark. I think yesterday's was about 18-minute presentation, so let's just get through this quickly. Okay, our content objective for today is that I want you to be able to understand renewable and non-renewable energy. For your language objective, I want you to be able to do a little bit more than talk about these things. I want you to be able to talk about specific elements of these two energy sources. Specifically, I want you to be able to talk about the drawbacks of non-renewable energy, such as fossil fuels, and the challenges of renewable energy. Because renewable energy is not some sort of magical solution to our energy problems. There are some complications and challenges that we will face with renewable energy. So let's just go ahead and start by talking about non-renewable energy. To renew something is to make it new or to replenish something that's depleted. And when we talk about non-renewable energy, this is energy sources that we cannot replenish once we deplete them. And so what we're talking about specifically is fossil fuels, specifically coal, oil, and natural gas. One of the big problems, as we talked about with fossil fuels, is their production of CO2, and CO2 is causing global warming, and 87% of the CO2 emitted by humans in the last 50 years comes from fossil fuels. The majority of that is in energy production, although a big chunk of that also comes from transportation, cars. Okay. Nuclear energy is also another form of non-renewable energy, and so the creation of nuclear energy relies on two non-renewable resources. One is uranium and the other is plutonium. Basically, the way nuclear energy works is it's pretty much the same as burning fossil fuels, except you just use the nuclear decay of some sort of either uranium or plutonium to heat water. That water creates steam, that steam turns a turbine, and that turbine creates electricity. Same thing with your fossil fuels. When you burn fossil fuels, you burn fossil fuels to heat up water. That water turns to steam. That steam spins a turbine, and that in turn creates energy. One thing a lot of people don't know, and I'm not going to show you any pictures of fossil fuels because we've been over that a lot recently, but one thing a lot of our students don't know is that there's a nuclear power plant very close to Minneapolis, and that's the Monticello Nuclear Power Plant. This is a picture of the nuclear power plant in Monticello. One thing you'll notice is that it doesn't have the sort of distinctive concrete smokestack. That's kind of this hourglass shaped smokestack that most people associate with power plants. That's not here at Monticello, but they're still creating energy by using nuclear fuel, such as, I don't know if it's a uranium powered power plant or a plutonium powered power plant. I'm not sure about the details of this power plant. Anyways, you can take a look at this map and you can see that Monticello is very close to Minneapolis. So if there was a problem such as a nuclear meltdown or an explosion, then that radiation would certainly fall all upon us as well. Now that we know about non-renewable energy, let's talk about renewable energy. One type of renewable energy that people talk about a lot, sounds really fancy, is biomass. They'll even have like fancy pictures and graphs to talk about what biomass is. And yes, corn or sugar can be sort of mashed up and fermented to create a type of alcohol called ethanol, and that ethanol can be used to power cars. But more often than not, when we talk about biomass, we're just talking about this: burning wood. Burning wood is one form of biomass energy. Wood is a renewable resource because we can cut down plants, we can burn them, and then we can grow the plants again. However, burning wood creates a ton of CO2. It actually creates more CO2 than burning fossil fuels. So in Korea, biomass was a form of energy that was used by very poor people, and still used by some poor people today to keep themselves warm during the winter. This is called yontan, which is it's like charcoal. And so basically they create charcoal by burning wood and in a low oxygen environment, and then it kind of blackens the wood and sort of removes some of the chemicals, I guess, that cause smoke from burning the wood. So when you have charcoal, there's less smoke, but it still emits plenty of carbon dioxide and carbon monoxide. And so people use these to heat their homes, and when you're heating your home with yontan, you run the risk of suffocating yourself because it's releasing carbon dioxide and carbon monoxide in the air. And this is just a very common story that people have, especially in older generations, of people who lit their yontan to keep themselves warm during the winter. They went to bed and they woke up and family members had died, or they knew someone who had died, something like that. Anyways, this is an example of biomass. It sounds very fancy, but it just means burning living stuff in order to generate heat or fuel. Next, we have hydroelectric power. Hydroelectric power is simply, when you make a dam, and that dam in turn blocks off water, and then you use the energy from moving water to spin a turbine. That spinning turbine in turn generates energy. And we'll talk a lot more about hydroelectricity, not only in this presentation but also next week as well. So continuing on with renewable energy, and wind, of course, we can see in the background there's a wind turbine, and wind is one form of renewable energy. And another form of renewable energy is wave or tide energy. Now, this is something I had to kind of look up because it's kind of listed as a form of renewable energy, but I don't think it's a type of renewable energy that people are really sort of channeling resources into harnessing. I guess one of the problems with wave or tide energy is that you can only harness this type of energy at the coasts. And if people inland need energy, then it becomes very difficult to transfer energy over that long distance. So anyways, wave tide energy, that's something that people have looked into. And basically it involves the movement of waves or tides to spin turbines. Those turbines spin and they create electricity, and then that electricity is channeled out towards the land where people can use it. So lastly, we have solar energy. Solar energy is actually a lot different than these other form of energies because it doesn't involve spinning a turbine. Solar energy is created by these, I forget the name of the cells, it's the photo something cell. But anyways, there are these cells, these black cells, these black squares that you see here. Once they get sunlight, once they receive sunlight, then it sort of moves electrons along these cells, and those moving electrons create electricity. And so those are different types of renewable energy. I think I'm forgetting one more form of electricity, or one more form of energy, which is geothermal energy, and that's generated from volcanic areas where the ground is very hot, deep down to the ground, and so they'll pump water into sort of these hot areas underground. That water will heat up, it'll create steam, that steam turns a turbine, you get electricity. So now I just want to talk briefly about problems of hydroelectric power. So hydroelectric power, it's a type of renewable energy, but it has tons of problems. And let's just talk about some of these problems here quickly. We're going to talk in more depth about this on Monday. We're going to have a lecture about the, and I don't know if I'm pronouncing it right, it's the Hatchi Dam. And this is a dam that's being built in the Karen state. It's a joint venture between the government of Myanmar, the government of Thailand, and the government of China. Unfortunately, the Karen people haven't agreed to the building of this dam, and so there's a lot of bitter fighting over actually constructing this dam. And also, as you know, Karen people are kind of being forced into slavery in order to construct this dam as well. Nonetheless, beyond those kind of social and, I would say, political conflicts over hydroelectric dams, there are also just some environmental problems with the dams themselves. So when you create a dam, you end up creating this floodplain behind the dam, and when you flood that area, lots of living things die, especially vegetation, and that rotting vegetation releases CO2 and methane, which is also a greenhouse gas. In addition to that, you change the waterway on both sides of the dam, and one of the things that results is that you create this lake behind the dam that holds a lot of very stagnant water, and the water doesn't circulate, it doesn't move a lot, and so oxygen levels drop. Excuse me. Sediments and nutrients build up, so algae will grow a lot. And then the nutrients and sediments that typically flow down a river all get backed up behind a dam, and so they're not equally distributed all along the length of a river. And this has a big effect on what we call floodplain farming. There's a lot of farmers, and there's a lot of agriculture that depends on sort of these sediments and nutrients flowing downstream, downriver, and when the rivers kind of flood, the sediments kind of wash over onto the land, and when the floods go away later during the spring, then the farmers have sort of nutrient-enriched fields which they can farm on. However, when you build a dam, that kind of stops this whole process. So another drawback of a dam is that fish cannot travel upstream, so nutrients can't travel downstream. Fish and other animals that live in the waters, they can't travel upstream. So renewable energy also has some challenges as well, and one of the big challenges of renewable energy is that demand for this energy kind of goes up and down, and so when you're burning stuff, you can just burn more stuff to meet energy demands. However, let's say with wind energy, if the wind isn't blowing hard, then there's no way to harness that energy if it's not blowing. Also, let's say people need energy, they need more energy. Let's say it's a real hot day, people are running air conditioners, they need more energy. There's no way to make the wind blow harder to turn those turbines faster to create more energy. So meeting energy demand is a real challenge for renewable energy. And we could even talk about this in respect to solar energy. What if people want to use energy at nighttime? Okay, how do we do that with solar energy? So meeting energy demand at different times is a challenge for renewable energy. Transporting energy is another challenge, and so I talked earlier about harnessing tide energy, and if you are trying to harness energy from waves or tides, that energy comes from the coast, comes from oceans, and you would need to transport that inland. And one of the problems is when you're transporting energy, you lose energy in more and more energy the further and further that energy has to travel. The energy has to travel through some kind of electric wires or cables, and there is essentially what we would think of as friction. It's called impedance or electrical resistance, and that just basically reduces the amount of energy that finally gets to you, depending on how far away you are from that initial energy source. So transporting energy is a real big challenge in terms of renewable energy, because you can create it on a wind farm, or you can create it like out by the ocean, but you have to transport it to a place where people can use it. And I think I talked about all of those problems in terms of wind, geothermal, and solar farms. We can see an image here of a wind farm in Australia, and you can see these big square boxes that are at the base of these wind turbines, and those big square boxes are batteries. So that's one way that they're trying to address the problems of meeting energy demand, is by storing all of the energy generated by these turbines and batteries, and then when people need more energy, they release it from these batteries into the electrical grid. And here is a picture of just a real sort of tangled mess of electrical wires, things that we need to transport energy from point A to point B. So I think this is our last slide, and this is it for the presentation for today. I'm at 15 minutes again. I made 7 slides, so I thought I was going to be able to breeze through this material easily. I apologize for taking so much time, but hopefully you're able to have a very clear understanding of this topic. And if you have any questions, as usual, please hit me up, sjkwok@sejongacademy.org. You can also talk to Mr. O at hoh1@sejongacademy.org. I also have office hours every day, 9:30 to 10:30 a.m. And finally, I did want to mention that on Monday we'll have a lecture in PowerPoint on the Hachi Dam. And so if yeah, if you're interested in this topic, or maybe you can talk to your parents too and ask them if they know anything about this dam that's being built. And it's along the Salween River, and so that goes right along the border of Thailand and Burma, right along the Karen State. And it's actually, the dam is going to be in the Karen State. And so yeah, just if you're interested in this topic, you can ask your parents if they know anything about it. I'd be interested in hearing any information any of you may have about this project. If you don't, no worries. I'll share what information that I have, and I'll share some documents that I have about this project as well. So thank you. Have a great day. And on Thursday, tomorrow, we'll have a live review session as well. So please come to class at 1:45. Thanks. Peace.